Hello everyone, welcome to Neso Academy. Till now we have studied arithmetic operators, logical operators, relational operators and shift operators. Today we are going to complete the remaining two operators, concatenation and miscellaneous operators. So, in this lecture, we will cover the following topics. The very first, concatenation operator, and the last topic is miscellaneous operators. Now, before understanding what is concatenation operator, let us do a quick recap. We all know what are operators, and in VHDL there are 6 operators, out of which we have completed the first 4 operators. Now, as I told you, we will understand the remaining 2 operators, concatenation operator and different types of miscellaneous operators, starting with concatenation operator. Now, what is concatenation operator? Concatenation operator is used to join multiple bits, signals, or vectors into a single vector. That is, concatenation operator is used to merge multiple bits, signals, or vectors into a single vector. In simple terms, concatenation operator is used to join multiple binary bits. Example, I am taking two signals, A and B. Signal A as standard logic vector 3 down to 0, meaning signal A as 4-bit standard logic vector, and here I am assigning a fixed binary value 1011 to this signal A. Now signal B as standard logic vector 2 down to 0, meaning signal B can store 3-bit standard logic vector. Example 101. Now, I want to merge these two signals 1011 and 101. So, I want to join these two signals A and B using concatenation operator. For that, I will perform concatenation operation and store the result inside another signal. Example, signal X with same data type standard logic vector and the length 6 down to 0, which is 7-bit. Why 6 down to 0? Because here we are merging a 4-bit vector to this 3-bit vector. 4 plus 3 equals to 7. Therefore, 6 down to 0. Now we can use concatenation operator to merge signal A with signal B. Let's see how. Here I am writing the operation A ampersand B. Now, concatenation operator is represented by ampersand symbol. So, A ampersand B and store the result inside this signal X. Here we are merging signal A and signal B. So, the result will be 1011 signal A, 101 signal B. So, using concatenation operator, we can merge two different vectors. Now, what if I want to merge a single bit with a vector? Can we do that? Yes, we can. For example, we can merge a single bit, let's say 0, at the start of this signal A. And also we can merge a single bit, let's say 1, at the end of this signal A. Now let's see how to perform these operations. For that, I am creating two signals to store the results. Signal YZ as standard logic vector 4 down to 0. Now, why 4 down to 0? Because we are adding a single bit to this 3 down to 0, means 1 plus 4 bit equal to 5 bit. Now let's see the operation using the ampersand operator. Here 0 ampersand A, meaning adding 0 at the start of the signal A. So Y will store 0, 1011 signal A. Similarly, we can write A ampersand 1, meaning adding 1 at the end of the signal A. The Z will store 10111. 1011 signal A and 1 at the end. So I hope you understand how to perform concatenation operation and how to merge different signals at the end or at the start of a vector. Also, we can use multiple concatenation operators to merge more than two vectors. Now let's see how to do that. For that, I am creating three signals, signal A, B, C. All are of standard logic vector type. Signal A as 4-bit vector equal to 1011. Signal B as 3-bit standard logic vector equal to 101. and signal C as 2-bit standard logic vector equal to 1, 0. Now we can merge these three signals using multiple concatenation operators. To be precise, using two concatenation operator, we can merge these three signals. Now, after merging them, we need to store the result. For that, I am creating another signal, example, signal Y with same data type, standard logic vector, 8 down to 0. Now, why 8 down to 0? Because we are merging 4-bit with 3-bit with 2-bit. 4 plus 3 plus 2 equal to 9-bit. Therefore, signal Y is of 9-bit. Now let's see how to use two concatenation operators. Here, A ampersand B ampersand C, and storing the result inside the signal Y. Now Y will store the overall merged value of A, B and C. So the output will be 1011 signal A, 101 signal B and 10 signal C. So using multiple concatenation operators, we can merge multiple signals, which means we are done with our first topic, concatenation operator. Now let's see miscellaneous operators. Miscellaneous operators, VHDL contains some special purpose operators, which I am calling as miscellaneous operators. And under miscellaneous operators, I have kept two special operators. First, absolute operator or ABS operator. Second, inversion operator or NOT operator. We will understand each of them, starting with absolute operator. Absolute operator or ABS operator. Absolute operator returns the magnitude of a number, meaning absolute operator returns the non-negative value of a number. Let's make it more clear using an example. For that, I am declaring three signals A, B, Y as integer data type. Now, if I want to calculate the difference between signal A and signal B and store the result inside the signal Y. Now, I want to store only the magnitude of the difference. Then, I can use the absolute operator. So, absolute operator is used to calculate the difference of two signals, regardless of which is larger. How to use absolute operator? Let's see. Here I am assigning Y as absolute of A minus B. So, this output Y will store the magnitude of the difference A minus B. Or even we can convert the minus number into a positive number. Example, signal X as negative integer minus 23. We can use absolute operator to convert this minus 23 into a positive 23. How to write Y assigned to absolute of X. So Y will store positive 23. Overall, absolute operator returns the magnitude of a number. And I hope you understand how to use an absolute operator. Let's see the second operator, inversion operator or NOT operator. It is exactly similar to NOT gate. NOT operator inverts the value, meaning 0 becomes 1 and 1 becomes 0. Let's understand this using an example. For that, I am declaring a signal named value with standard logic data type and assigning a fixed value of 1. Now, if I want to invert this value, means I want to convert this 1 into 0. Then I can use this NOT operator. I will write Y is assigned to NOT value. So, this signal Y will store 0. Now, not only a single bit, NOT operator can also invert an entire vector. Example, signal A as standard logic vector 3 down to 0, meaning signal A can store 4-bit standard logic vector, example 1011. Now we can use NOT operator to invert this vector, and we need a signal to store the result. For that, I am creating another signal B with same data type and same length. Now let's see how to perform the operation. I will assign B as NOT of A. Now this signal B will store the invert value of this vector A, which is equal to 0, 1, 0, 0. So this is inversion operation, and I hope you understand, which means we are done with our second topic, miscellaneous operators, which means we are done with this lecture. I will see you in the next one. Thank you.